Betelgeuse's possible supernova is one of the most captivating cosmic phenomena. Betelgeuse, a crimson supergiant approaching the end of its life cycle, can be found on the well-known shoulder of the Orion constellation. One of the brightest stars in the sky, it began to noticeably dim in 2019, making it visible even to the unaided eye. Numerous observers wondered if the star was dying after its brightness decreased for several months. The evidence of this significant dimming astonished researchers as they aimed their telescopes at the massive star. It is believed that Betelgeuse is about to explode into a supernova, signaling the end of its stellar existence. However, when and why will this cosmic explosion occur? Could it have devastating effects on our planet? Betelgeuse, a brilliant, scarlet star, is displayed on Orion the Hunter's upper right shoulder. It may be known by its alternative name, Alpha Orionis. Despite being the second brightest star in that constellation, after the supergiant Rigel, it continues to pique the interest of researchers due to its erratic behavior and distinctive name. In most constellations, the brightest stars are alpha stars. Betelgeuse also draws attention because of its enormous size and reddish hue, despite the fact that Rigel is brighter than Betelgeuse. Betelgeuse, also known as Alpha Orionis, is one of the most well-known stars in the night sky. It is the 10th brightest and the 7th most visible for a large portion of North America, Europe, and Canada. Arabic-derived, its name refers to the giant's armpit and its position within the group of stars. Every 10,000 years, Betelgeuse sheds about one solar mass, releasing substances uniformly in all directions and creating a nebula around itself. This nebula is 250 times heavier than the star itself and spans 30 astronomical units, or 30 times the distance between Earth and the Sun. Betelgeuse's hydrogen nuclei combine under enormous gravitational pressure at its core, producing helium and radiating heat and radiation. The star starts fusing carbon and helium to replace hydrogen as it runs out. Neon combines with carbon to make iron when helium runs out. The star collapses under its own gravity and eventually explodes in a supernova because iron fusion fails to produce any energy. Stars produce light with varying wavelengths, making them some of the most powerful explosions in the universe, from the bright blue of young stars to the red of old stars. Betelgeuse, whose color was intriguingly referred to as ruddy by the ancient stargazer Tommy, was noted by early Chinese astronomers as having a yellow hue, suggesting that it may have been a yellow supergiant in the past. Even though massive stars only last 10 million years, they quickly exhaust all of their hydrogen, resulting in an early death. There is no doubt that Betelgeuse is coming to an end. Betelgeuse may one day explode in a supernova, despite the fact that it still has more than 5 billion years of life left in it. However, it is still unknown when exactly this will occur. Betelgeuse goes through two brightening and fading cycles, one that occurs every 5 years and lasts about 100 days. It is assumed that during these rhythms, changes in its diameter and typical surface temperature are brought about by the swelling and shrinking of its outer layers. Betelgeuse's unpredictable behavior in 2019 and 2020, when its light dramatically faded before briefly returning, fueled widespread interest. This strange activity could be a sign that the star is about to undergo its final transformation, according to some scientists. Betelgeuse has been the subject of extensive research since the 1st century BC. However, the cause of its dimming remains a complete mystery. Betelgeuse has been observed traveling at about 30 kilometers per second through the interstellar environment. The bow shock that occurs as a result of the objects being thrown from the Orion OB1 group, which contains the stars of Orion's belt, extends beyond 4 light years. In astrophysics, it is notoriously difficult to measure the distance to red supergiant stars like Betelgeuse because a variety of factors make it difficult to estimate their diameters accurately. Betelgeuse's size also changes over time because it is a pulsating star. Its observed glow changes color and diminishes as we get closer to its core due to this characteristic and the dimming of its outer edge. In addition, the star's material shell plays a crucial role in light absorption and emission, also influencing our interpretation of its brilliance. Betelgeuse's visible size changes depending on the wavelength seen, making it difficult to contrast two views of it directly. Depending on the wavelength of light used, these measurements can vary by up to 35%. One of many mass expulsions observed from Betelgeuse was revealed in images taken with the European Southern Observatory's VLT interferometer at its ground-based observatory in July 2009. The images were taken with a very large telescope. This flow corresponded. The angle of separation between Neptune and the Sun, Betelgeuse, has been the scene of at least 6 of these incidents. The question of mass ejection in the final periods of massive stars, which may be central to their destruction, may be answered by these occurrences. Betelgeuse's extended upper layers, intricate processes, and the precise method by which red supergiants release their matter remain baffling. Due to advancements in interferometry, these stars are essential to the movement of elements within galaxies. These riddles are getting closer to being solved by astronomers. Betelgeuse had blown off a significant portion of its outer shell, triggering a significant surface mass ejection, or SME, according to researchers who used the Hubble Space Telescope and other observatories in 2019. Betelgeuse's events were thousands of times more extreme than the Sun's mass ejections, releasing material 400 billion times larger than in a typical solar eruption. This is why Betelgeuse experienced a significant decrease in luminosity in October 2019. It had decreased from magnitude 0.5 to magnitude 1.7 by the middle of February 2020, having lost nearly 3 times its brightness. Betelgeuse's brightness had remained largely constant for more than a week by February 17, 2020. On the 5th, it appeared as though the dimming had completely stopped. However, no significant changes in infrared radiation were detected on February 24, 2020, suggesting that the recent decreases in visible light were unrelated to a possible collapse of the core. Feel free to leave your thoughts in the space provided for comments. If you enjoyed this video, please give it a thumbs up and subscribe so you don't miss any more. Betelgeuse's final explosion as a supernova will be one of the most dramatic cosmic events ever recorded. The blast will be so bright, even at a distance of 640 light-years, that it could outshine the full moon and be visible in the daylight for several weeks or even months. The supernova, according to experts, will produce more energy in a matter of seconds than our sun will produce over the course of 10 billion years. The explosion's light will travel through space quickly and eventually reach Earth as a brilliant point of light. We have never seen anything like it, but rest assured that we are completely safe. Betelgeuse is far enough away that the detonation will not harm Earth's biosphere or living things, despite the fact that a supernova that is this close may sound dangerous. It will provide a remarkable scientific occasion. Betelgeuse has returned to typical brightness levels over the past few years, but its irregular dimming patterns are still closely monitored. Space telescopes like the Hubble Space Telescope and land-based interferometers like the VLT and ALMA are being utilized by scientists. They are keeping an eye on changes in surface light, patterns in convective activity, and persistent mass outflows that appear to indicate the star's instability. One well-supported theory is that one such eruption resulted in a huge cloud of starborn dust that temporarily obscured the star's light from our perspective, causing Betelgeuse to significantly fade. Astronomers may be able to decode the life stages of massive stars, particularly those that are about to undergo a supernova, if they are able to comprehend the mechanisms that underlie Betelgeuse. Understanding the formation and dispersion of elements like iron and gold across space, as well as how chemical elements enrich the cosmos, could help predict similar phenomena in other galaxies. Betelgeuse is, in essence, a cosmic time machine that is slowly coming to an end. It could explode today, next year, or 100,000 years from now. However, whenever it does, it will present a galactic spectacle as well as an unparalleled quantity of scientific data. Betelgeuse's life and death are more than just a matter of academic curiosity. It has a significant impact on how we understand the universe as a whole. Heavy elements are formed in the forges of massive stars. These elements are scattered into space when these stars reach the end of their life cycles and explode in a supernova, enriching the surrounding interstellar clouds with the building blocks for new stars, planets, and even life. The upcoming supernova of Betelgeuse presents a unique opportunity to study such an event in close proximity. The majority of supernovae observed by modern science are located in faraway galaxies, limiting the amount of information and detail that can be gathered. However, due to Betelgeuse's location in our own Milky Way galaxy and relative astronomical proximity, astronomers will be able to observe the explosion and its aftermath with unprecedented clarity. For researchers of neutrinos and gravitational waves, this possibility of observation is especially exciting. A star's collapse into a supernova produces more than just visible light. It might cause space-time ripples that can be seen because it releases a lot of neutrinos. Detectors like IceCube, LIGO, and Virgo would be able to capture this data if Betelgeuse went supernova. This would give new insight into the physics of stars and the fundamental forces of the universe. Betelgeuse is also getting a lot of attention from astronomers because of what it can teach us about stellar behavior in general, not just because of the possibility that it will die. Betelgeuse and other red supergiants remain among the most obscure phases of stellar evolution. They are enormous, unstable, and challenging to accurately model. That is changing as a result of advancements in high-resolution spectroscopy and space telescopes. However, numerous inquiries remain unanswered, questions that might soon be answered by Betelgeuse. Betelgeuse continues Irgende, pulse, and surprise us in the interim. Despite the fact that, for the time being, its brightness appears to be stable, researchers remain vigilant and are prepared to document any changes in the event of a supernova. Our understanding of how stars live and die could be transformed by the collected data. Betelgeuse will continue to be a focal point in the night sky and in the imaginations of astronomers worldwide until that time comes, whether it be tomorrow or millennia from now. It serves as both a cosmic countdown and a celestial marvel. Notes: